How to choose motors for multi-copter drones. Presented by RC Airplanes Victor. Several subscribers have asked me how to choose the motors for drones. And although the video I presented how to choose an electric motor and the propeller for your RC airplane is applicable, we will present here the process for drones of any number of motors. We are not going to present how to build a drone from A to Z. Just how to choose the motors and propellers for those aircraft. As each motor of a drone has to have a speed controller, the video that I made to choose those controllers also applies. Here the link. The same for the choice of the battery, only that it is necessary to take into account the total consumption of all the motors. The steps that we are going to follow are: 1. Estimate the total weight of the drone. 2. Choose the thrust to weight ratio. 3. Calculate the total thrust needed. 4. Choose the motor kV, according to the use of the drone. 5. With the kV, find the power to thrust ratio. 6. With the power to thrust ratio and the necessary thrust, calculate the necessary power. 7. With power and kV, choose the motor from a supplier or vendor. 8. Select the propellers. Step 1. The first thing we have to know or estimate is the total weight of our drone. For this we can make an estimation table like the one presented in the next slide. In this table we have listed the components of the drone with its estimate weight. The estimated total weight is 1,545 grams or 54.5 ounces. Don't worry if the weight is a little overestimated. Step 2. Choose the thrust to weight ratio. For a drone, which is kept in flight by the thrust of the propellers, the thrust to weight ratio should be between 2 and 4, to make sure we have enough thrust with the throttle halfway. The value 2 for slow drones and the value of 4 for racer drones. Let's choose as an example, the value 2.5. Step 3. Calculating the necessary thrust. With the thrust to weight ratio equals 2.5 and the estimated weight of 1,545 grams, we calculate the total thrust required. Thrust equals thrust to weight ratio multiplied by weight. Thrust equals 2.5 x 1,545 grams equals 3,863 grams. Now remember that this thrust is distributed among the 4 motors, so the thrust for each motor will be 3,863 divided by 4 equals 966 grams. We can generalize saying that if n is the number of motors, then we divide by n to find the thrust per motor. Step 4. Choose the kV of the motors. Choosing the kV is choosing the speed of translation of the drone. If we want to take pictures, we do not care about the speed, we choose a low kV, but if we want a race drone then we choose a high kV. It must be taken into account that the higher the kV, the more power is needed to produce a certain thrust. This table is a guide to choose the kV of the motor. These are experimental values from my test bench. Note that lower the kV, more thrust per watt is obtained, but lower the air speed. So choose the kV according with your needs. Step 4. Choose the motor kV. Let's suppose we want a drone that will help us take pictures and videos, but that would be not so slow. For this I will choose a kV of 2000 approximately. Most drones have a kV less than 1000. Now with the kV and the necessary thrust, rounded to 900 G per motor, we will find the necessary power. Step 5. Find the power to thrust ratio. Now with the kV we can find the power to thrust ratio using table 3 obtained from my test bench. This table presents the values of the power supplied to the motor, in watts, divided by the thrust produced by such motor, in grams, for every kV. Table 3. Power to thrust ratio expressed in watts per gram or watts per ounce according to the motor kV. We can use the equation presented on the upper right corner. For a kV of 2000 the power to thrust ratio is 0.43, in red. For a kV of 100 this ratio is 0.26, in blue. Step 6. Calculating the necessary power per motor. From Table 3 with kV 2000, the power to thrust ratio is 0.43 watts per gram. Now with the power to thrust ratio and the required thrust per motor of 900 grams, we find the power. Power equals 0.43 multiplied by 900 equals 387 watts. Every motor of the drone must have at least this power. Step 7. Choose the motors. Now we have the kV equals 2000 and the power W equals 387 watts. We go to the catalogs of suppliers and find, for example, G2306-2200 kV, Racing Edition Brushless Motor. Here the link. The important points from the specifications are 2200 kV, shaft diameter, 4 mm. Weight, 32 grams. Battery number of cells, 3 to 4S. Maximum continuous power, 490 watts. Maximum current, with 3S 33 amps. These are the data that gives the Hobby King page for this motor. This table gives the propeller size, the battery voltage, the percent throttle, the amps of the motor, the thrust in grams and the power in watts. Note the value of thrust for 50% throttle, in blue, and 100% throttle, in red. We see that with 6 by April 5 inches propeller of N4S, 14.8 volts, battery, the motor produces 1147 grams of thrust. We wanted 900 grams, at a power of 399 watts, we had established 387 watts. Note also that the current consumed is 27 amps, which will be the data to choose the speed controller or ESC. I would choose one of 35 to 40 amps. Note too, from the same table, that at 50% throttle the motor produces 473 grams of thrust. With 4 motors it would be 1892 grams. Since our estimated weight is 1545 grams, step 1, we can flight half throttle comfortably. As mentioned previously, low kV motors are more efficient, they produce more thrust with less power, than those of high kV. For example, if we had chosen 1000 kV instead of 2000, the power to thrust ratio of the table gives 0.260 watts per gram, so the power needed would be power equals 0.26 multiplied by 900 G equals 234 watts. Which is much smaller than the 387 watts of the previous example with 2000 kV. If we look for a motor with kV 1234 watts, we find, for example, the one shown on the next slide. Motor Multi-Star Elite 2312 980 kV. The important points from the specifications are kV, 980. Battery LiPo cells, 3S maximum. Power 230 watts, maximum amps, 18A. Since the seller's page does not give the thrust data, we have estimated it using Table 3. Thrust equals power divided by power to thrust ratio. Thrust equals 230 divided by 0.24 equals 958 grams. Which complies with what we want, 900 grams. Considerations about flight time. Using less power has to do with the flight time. Remember that the flight time can be estimated by the expression flight time, minutes, equals milliamps hour of battery multiplied by 60, divided by the motor amp, divided by number of motors. For example, for a 5000 mAh battery, the flight time for the G2306220 kV motor that consumes 27 amps maximum, and if we use 4 motors, would be flight time, in minutes, equals 5 multiplied 60, divided by 27 divided by 4, equals 2.77 minutes. For the Motor Multistar Elite 2312, 980 kV, that consumes 18 amps maximum, with 4 motors. Flight time equals 5 multiplied by 60 divided by 18, divided by 4 equals 4.16 minutes. Both flight times are calculated with motor at full amperage, so they are conservative, which means you can fly longer. Considerations about the battery. Of course, the battery will be in accordance with the flight time that we want, and if the weight can be supported by the drone. Using the expression shown, we can choose the battery by placing different values of milliamps hour. Remember that we can use a single large battery or 2 or more batteries in parallel to power the motors. Step 8. Select propellers. The size of the propellers are normally recommended by the manufacturer for the specific motor. In case the manufacturer or vendor does not specify the size of the propellers, they can be chosen according to the criteria that I formulated in my video on how to choose the motors and the propellers. The following table 4 is the same table I used in the above mentioned video. This table gives the propeller diameter, or the rotor diameter in case of EDF, according with motor kV. In red you can see that for the 1000 kV motor, the propeller diameter is 10 inches. In blue, for a 2200 kV motor, the propeller diameter is 6 inches. But, what about the propeller pitch? The pitch of the propeller will depend on the reaction we want with the aircraft. Normally the pitch will be between 4 and 7 inches. Low pitch means more thrust and less speed. High pitch means less thrust and more speed. So, for the first motor, 2200 kV, the propeller would be 6 by 4 for example, and for the second motor, 980 kV, the propeller would be 10 by 7 or 10 by 4.5. I hope this video has been illustrative and that it gives you a base to choose your motors and propellers. Until the next video, and happy flights! Don't forget to subscribe to my channel RC Airplanes Victor to receive notice of the new tutorials and videos of the channel.